In this mini lesson, we're going to refresh your understanding of equations and then look at a good basic default strategy you can use to solve any equation. So just a couple of highlights. I think these are things you already know. Equations always have an equal sign, and you solve equations to find an unknown value. So you're really looking for the value for the variable that makes the equation true. Now, we talked about this in class a little bit today, but the main purpose of equations in algebra is that they pose questions. They allow us to ask a question that we can answer. And there are really kind of two flavors of types of questions. Here's an example, 3x plus 2 equals 20. And this is really asking the question, when is this pattern equal to 20? Or another way to phrase that is, what must I input into X so that this pattern, when I evaluate it, it outputs 20? Another question that is when we have variables on both sides. For example, 3x plus 2, this pattern is equal to 2x minus 6. And this is asking the question, when are these two patterns the same? And you might want to phrase that by saying, what value would I have to input into X so that both of these patterns output the same value? Now, once you have an equation that poses a question, you just have to solve the equation to find the answer to that question. All right, next up, let's look at some basic strategy for solving equations. There are many, many different ways to solve an equation, but what I'm going to walk through with you today is just a good basic default strategy that will always work to solve equations. And this strategy really has 3 steps. So the first step is to simplify both sides of the equation. So I'm going to say simplify both sides. And let's come over to this example and we'll do each step as it comes along. All right, so we've got a lot to simplify in this equation. Let's start. I notice I'm going to have to use the distributive property here and the distributive property there. So let's go ahead and do that. All right, so this is helpful for me. I'm thinking I want to really add -3 because it's -3 that I want to multiply by both x and 4. All right, then we have -2 minus 6x plus, let's go ahead and use the distributive property, 2 times x, 2x plus 2 times 8, 16. And let's come back here. X plus -3 times x is -3x plus -3 times 4 is -12. And we'll go for here. Okay. My next step when simplifying is I want to combine my like terms. So here I've got an x and a -3x, which will give me -2x. And I'll go ahead, that double sign, minus 12. Over here, I've got -6x and positive 2x, -4x. And then I have a -2 plus 6, which will give me plus 14. Awesome. Both sides are simplified. Okay. Next step in the basic strategy is if you have variables on both sides, combine the variable terms on one side. All right, let me change my colors for this. Okay, and it doesn't matter if I put the variables on this side or this side. It's really mathematician's choice. I don't know, I'm in the mood, I'm gonna put them on this side. Okay, so that means I need to turn this entire variable term into 0 because it's being added to 14. So to do that, since it's -4x, I'm going to add 4x to both sides of the equation. All right, -2x plus positive 4x gives me 2x minus 12. And -4x plus a positive 4x gives me 0, and 0 plus 14 is 14. Awesome. Combine variables on one side of the equation. All right, then the very last step is now we're ready, let's isolate the variable. Isolate the variable, and that just means we want to get the variable all by itself on one side of the equation, and then you'll find the solution on the other. And really to do this, to isolate the variable, what we want to do is we want to undo operations, and And we're going to do this since we're working backwards, since we're undoing, we're going to work backwards through the order of operations. So I'll say undo operations by working backwards through the order of operations. All right, so when I'm looking at my operations, let me change my color, I see I've got some multiplication and some subtraction. Since I'm working backwards, I want to undo the subtraction first. So to undo subtraction, I'm going to add 12 to both sides. Again, the goal is to turn that into 0. So we're left with 2x is equal to 26. Now I want to undo that multiplication, and to undo multiplication, I'm going to divide. So 2x divided by 2, and whatever I do to one side of the equation, I do to the other, and x is equal to 13. So if we go back to this original example, it's really asking, when are these two patterns, and they're pretty complex patterns, when are these two patterns the same? And by solving the equation, we found out, oh, well, this pattern is the same as that pattern. They output the same value when we put 13 in for x, when we input it for x. All right, so again, solving equations, there's so many different ways to do it, but this is a great basic strategy that will always work to solve any equation. All right, I hope you found that helpful. See you next time.